For weeks, the scientific community has been in a state of anticipation, waiting and watching closely to see when China would finally unveil the data. While NASA, ESA, and major observatories in the West wrestled with the sun's blinding geometry and a dust storm engulfing Earth's atmosphere, one spacecraft enjoyed the perfect vantage point. This solitary machine rose above the chaos, the uncertainty, and the excuses, silently orbiting Mars and equipped with instruments designed for clarity rather than political agendas. That machine was Tianwen-1. Tonight, the silence has shattered. China has just released the first confirmed images of interstellar object 3I, Atlas, captured from Mars's orbit during a time when every telescope on Earth was rendered blind. Combined with Tianwen-1's ultraviolet and dust monitoring tools, these images reveal an aspect of 3I Atlas that we were never intended to see, one that contradicts every prediction, defies all comet models, and amplifies the enigma surrounding this unpredictable visitor to our solar system. These new images do more than bridge the gap. They highlight it. They depict an object exhibiting behavior that is not only surprising but impossible. And now, with China's revelation, the world must confront a chilling reality. 3I. Atlas may not be what we believe it to be, and someone beyond Earth saw it first. This is the narrative of the Mars images that will compel humanity to reconsider everything we assumed about interstellar visitors. The document begins with a crucial detail: geometry. When Earthbound observatories lost sight of 3I, Atlas, Tianwen-1 was in a precisely aligned orbital segment, providing it with an unobstructed view across interplanetary space. There was no interference from sunlight, no atmospheric scattering, no horizon hurdles, just a clear, silent perspective above the Martian sky. While NASA's telescopes were blinded by solar proximity and ESA's fleet was forced to halt direct tracking, China's spacecraft maintained uninterrupted monitoring. The high-altitude orbit of Tianwen-1 permitted it to observe 3I, Atlas, as it traversed the critical period leading up to perihelion, when comets reveal their true nature, including fragmentation, tail morphology, energy output, and sublimation patterns. However, what Tianwen-1 recorded was not the violent fragmentation anticipated by Western models. It was not the chaotic breakup predicted by thermal stress. Instead, it observed a stable, bright structure that was accelerating. And as the document reiterates, while Western telescopes saw nothing, Tianwen-1 witnessed everything. The entire mystery of 3I, Atlas hinges on that straightforward fact. The first frame released by Tianwen-1 may not appear dramatic at first glance. It shows a faint point with a slightly elongated envelope. Yet, for scientists who grasp what they are seeing, it's a groundbreaking revelation. The observation reveals a massive dust coma that is not thinning or scattering, but rather thickening, stabilizing, and forming a symmetrical plume around the object. Every analysis of the visible wavelengths from the Mars orbiter confirmed this: a dense cometary coma, a jet structure directing sunlight, and a tail that is already measurable from Mars's orbit, with brightness significantly exceeding expectations. But the real shock lies here. The coma's brightness fluctuated in a periodic rhythm, presenting a pattern rather than appearing random or chaotic. Such patterns within interstellar objects are never overlooked. Tianwen-1's ultraviolet sensors detected a spike in UV reflectivity that corresponded perfectly with rotational models. However, the amplitude was too high for a small native nucleus. Something was either spinning faster than predicted or reacting more swiftly than the laws of physics would allow. This was not a quiet comet, but rather a vibrant engine of energy, and China possessed the sole camera aimed at it. As 3I, Atlas, drew nearer to the sun, European ground stations were utterly blind. The solar elongation angle made direct imaging impossible. With Earth facing directly into sunlight, any attempts to track the object would be lost in glare. Yet, orbiting Mars, Tianwen-1 had the uniquely advantageous position that avoided this solar obstruction. The document underscores a chilling phrase: Mars was the only eye left open. With all other observatories offline, Tianwen-1 captured the emergence of new jet structures in real time. It recorded the elongation of the comet's dust tail and the formation of the Anticola, a stunning plume stretching millions of kilometers. The Anticola developed far more rapidly than early models had predicted. This wasn't merely outward movement, this was a directed release, forming coherent lines instead of chaotic sprays. The document's authors observe, if a comet behaves like this near the sun, fragmentation must ensue, yet there was no sign of fragmentation. This moment marks when Earth lost control of the narrative, and Mars became the sole witness. The photometry from Tianwen 1 indicated something astronomers recognized instantly as impossible: a brightness increase of 0.3 magnitudes with no visible structural breakup during a phase in which fragmentation is expected according to classical models. Yet the nucleus appears coherent, and the coma remains consistent. This is the paradox expounded throughout the document 3I. Atlas exhibits the energy profile of a shattered comet, but retains the structural profile of an intact one. And this is why the images from Tianwen 1 are significant. They unveil the first contradiction in the laws governing cometary physics. An object cannot produce jets of this magnitude without revealing a surface area that no single body of its size should possess unless the object is hollow, has internal chambers, possesses a layered structure, or is not a comet at all. This moment elucidates why China hesitated before sharing the images. This data sparks not just controversy, but fear. Every instrument aboard Tianwen 1 converged on one conclusion: there is structure within the coma. It is not just dust, noise, or artifacts, it's structure. The document describes a dark ridge within the illuminated envelope, a region exhibiting suppressed reflectivity that should not exist if the nucleus were spherical or irregular. Its shape is distinct and repeats across exposures. The authors ponder its axial alignment regarding the jet, speculating whether it constitutes a density fold, a thermal shadow, or a geometric occlusion. One possibility is sidestepped by most conventional astronomers, except for one, Avi Loeb. Now, Tianwen 1 has produced the initial image, supporting his most controversial standpoint: the possibility that the nucleus of 3I, Atlas, is not a mere random rock, but rather a structured mass. If there's one detail in this document that stands out, it is this: Tianwen 1 detected a sudden brightening from the side opposite the sun. Comets typically brighten on the sunward side, sublimating under heat and ejecting material in the sun's direction. However, Tianwen 1 recorded the contrary, a brightening that contradicts physics. This moment is labeled by the Chinese researchers as an unexpected photonic inversion, suggesting that the object emitted or reflected light from its colder side as though something within it activated, pulsed, or released energy in response to solar input on the opposite hemisphere. The object behaved as if it possessed internal mechanisms, rather than simply melting ice. This observation represents the most significant red flag in the entire dataset, and it arrived from Mars. Once China shared the images, every Western agency immediately began reconstructing the previously missing data. Yet there is a palpable sense of resignation in the document, a feeling that Earth has lost its monopoly on astrometric truth. For decades, our planet served as the observer, the vantage point, the authority. But now, a probe orbiting another world has taken charge. The scientists reviewing Tianwen 1's findings acknowledge that the jet structures do not align with any Western models. The brightness evolution alters the orbital solution, while the absence of fragmentation contradicts the acceleration readings. The geometry of the dust tail is not compatible with a single coherent nucleus. The object must be either fragmented, hollow, or functioning under unknown physics. Nobody wants to declare the final conclusion categorically, but Tianwen 1 has forced their hand. This interstellar object is behaving not like a comet, but like something adaptive. The final segment of the document is philosophical, almost mournful, reflecting on the fact that we are observing an object older than our sun through machines that are only a short generation beyond our grandparents. It highlights the poetic irony that the inaugural interplanetary mission of a burgeoning space superpower has captured something that could rewrite our understanding of interstellar travel. The closing thought is profound. We anticipated dust, we expected ice, but what we did not expect was intention. That line resonates deeply because Tianwen 1 has provided the world with something no Earth-based observatory could offer: a view of 3I, Atlas, from above the noise, from beyond the sun, from another planet. The images do not resolve the mystery, they intensify it. For the first time, we are prompted to confront the possibility that the most significant interstellar discovery in human history was never visible in Earth's skies, but rather from Mars's. In conclusion, the most haunting aspect of this narrative isn't the brightening, the sunward jets, or the impossible Anticola slicing through millions of kilometers of space. It isn't even the dark ridge concealed within the coma or the photonic inversion that led scientists to whisper in private, nor is it merely the behavior of 3I, Atlas, which appears responsive rather than melting. The truly haunting element is that Earth witnessed none of it. For the first time in modern astronomy, this story shows that humanity's home planet was not the observer of its own cosmic history. Instead, the only eyes that remained open, the only camera that continued to observe while solar glare blinded all others, belonged to a machine orbiting a different world altogether, a machine built by a nation that refused to look away when everyone else had to. Tianwen-1 became humanity's singular window into the truth, and this truth is now impossible to dismiss. As the images returned don't narrate a comfortable tale. They do not illustrate a peaceful, predictable comet adhering to familiar principles. They do not reassure us that we are merely observing another interstellar rock passing through our neighborhood before disappearing forever. Instead, they depict an object that is shifting, pulsing, brightening from the wrong side, releasing jets in the incorrect direction, forming structures where randomness ought to reign, refusing to fragment when models dictate it should, collecting energy where a comet cannot. As if this entity floating through our solar system is not merely a remnant of cosmic chaos, but rather a remnant of something else entirely, something organized, structured, ancient. The silence accompanying the release, the empty pauses between each sentence in China's report, speaks louder than the data itself. There is no assertion, no theory, no sweeping conclusion, only the raw statistics, the bizarre images, the impossible behaviors left to linger in the air, like a question humanity is finally daring enough to consider. What exactly did Mars see? And why did 3I, Atlas, behave so differently when only one unwavering eye was focused upon it? This is the query that now weighs heavily on scientists around the globe. Not whether the object is alien, artificial, or engineered, but rather whether it is natural at all. Do the laws governing cometary physics rules we have trusted for centuries apply to something that did not originate in a comet-forming environment, did not evolve through the gradual violence of star systems, and does not carry the hallmarks of randomness, but instead bears the signature of intention, because intention is a singular force in the universe that cannot be fabricated. And Tianwen-1's images leave us with the disquieting prospect that intention might indeed be precisely what we are observing. So now the world awaits not for another theory or another press release, but for the next data drop, the next image, the next anomaly that will either deepen the mystery or finally unveil what 3I, Atlas, truly is. If this narrative has left you questioning what Tianwen-1 truly captured near Mars, don't let that curiosity fade. Subscribe to the channel because the next images could radically alter our understanding of interstellar visitors. Activate notifications when the next observation drops. You'll want to be among the first to see it. And let us know in the comments, do you believe 3I, Atlas, is a natural comet, or has Mars just witnessed the first interstellar system ever seen by human eyes?